Observe these two jars of marbles. The bigger jar contains 50 marbles more than the smaller jar. We do not know the number of marbles in the smaller jar. So, let's use the variable x to represent the number of marbles in the smaller jar. So, the number of marbles in the bigger jar would be the sum of x and 50. Now, let's form an expression to represent the sum of marbles in both jars. Well, there's no definite value for the variable x. It could be 10, 25, 45, or even 100. Now, what if we say that the total number of marbles in both jars is 170? Here, the expression 2x plus 50 gets converted into a simple equation. We have an equality sign and a value on the right-hand side. Note that an equation need not always have a number on one side. It can even have expressions on both sides. In other words, an equation must contain an expression on one side and a number or expression on the other side. Now that we've reviewed equations, can we say that these mathematical statements are simple equations? Observe the symbol between the left and right-hand sides in each of these mathematical statements. None of these symbols represent equality. In an equation, the left-hand side must equal the right-hand side. In each of these statements, the left and right-hand sides are not equal, and so these statements are not equations. Moreover, in these statements, we cannot find the exact value of x. We will only know whether x is greater or lesser than a particular value, but will not be able to find its specific value. Since an equation is the equality of left and right-hand sides, it must hold a definite numerical value for the variable in it. A variable in an equation has a specific numerical value, so in this equation, we cannot assume any value for the variable x. Let's use the trial and error method to find the value of x in this equation. For example, we assume 10 as the value of x. The sum on the left-hand side does not equal the value on the right-hand side, so the value of x cannot be 10 in this equation. What if we take x to be 25? Will the expression on the left satisfy the value on the right-hand side? As you can see, if we substitute x with 25, the equation is not satisfied. That is, the left-hand side does not equal the right-hand side. Next, we take the value of x as 60. The left and right-hand sides of the equation now become equal. Thus, 60 is a finite numerical value of the variable x in this equation. So x is equal to 60 is the solution of this equation. In general, if a particular value for a variable satisfies the equation, that is, the left-hand side equals the right-hand side, then that value of the variable is called the solution to the equation. Now that we've found the solution to this simple equation, we can say that the number of marbles in the smaller jar is 60 and the number of marbles in the bigger jar is 110. Let's take another example. In this equation, we do not know the value of x. So, we'll start by checking whether x equals 1 is the solution of this simple equation. First, separate the left and right-hand sides. Next, substitute the assumed value of the variable on the left-hand side. As the left and right-hand sides are not equal, x equals to 1 is not the solution to this equation. Next, let's take the value of x as -1 and see if it is the solution to this equation. Substitute x with -1 on the left-hand side. Again, the left and right-hand sides are not equal. So, x equal to -1 is not a solution to this equation. The solution of this equation is given by x equals to 2. Can a simple equation have more than one solution? For example, can x equal to 4 and x equal to -8 both be solutions to the given equation? A simple equation can have one and only one solution. In this case, x equal to -8 is the solution. We can use equations to represent real-life situations. Let's look at a few such situations. Anita's grandfather's present age is 6 years more than 3 times her present age. If Anita's grandfather's present age is 72 years, let's set up an equation to represent this situation. Let Anita's present age be x. Her grandfather's present age will be 6 more than 3x. We know that her grandfather's age is 72 years. So, the equation will be the sum of 3 times x and 6, which equals 72. Let's look at another example. The larger box contains 6 less than 2 times the cookies in the smaller box. If the larger box contains 24 cookies, form an equation that represents this situation. Let the smaller box contain x cookies. The larger box contains 6 less than the product of 2 and x, which is represented as 2x minus 6. Given that the larger box contains 24 cookies, we have the equation as 2x minus 6 is equal to 24. Now, observe the triangle ABC. It is formed by 16 congruent triangles. If the area of triangle ABC is 400 square units, let's form an equation to find the area of the small triangles inscribed in triangle ABC. The 16 congruent triangles inscribed in triangle ABC have equal area. Let the area of each small triangle be x square units. The area of triangle ABC is equal to the areas of all the triangles together. So, the area of 16 triangles together is 400 square units. Thus, this equation can be formed. The height of this door is 7 feet. Also, the height of the door is observed to be 1 foot more than 3 times the width of the door. Let's find the width of the door. Let's assume the width of the door to be y feet. So, the height of the door is 1 added to 3 times y, which is also equal to 7. Now, let's solve this equation to find the value of y, which represents the width of the door. We bring the like terms together by transposing 1 to the right-hand side of the equation. Then, we subtract. Then, we divide both sides by 3 and find the value of y. As y represents the width of the door, we know that the width of the door is 2 feet. We can quickly substitute y as 2 in the left-hand side of the equation. As you can see, we get the result as 7, which is the same as the right-hand side of the equation. Thus, our solution is correct.
Let us learn about maintaining the balance of an equation. An algebraic equation is a mathematical statement of 2 expressions being equal. Consider a weighing balance. If you add equal weights to both sides of the balance, or remove equal weights from both sides of the balance, the 2 sides will remain balanced. This is pretty much how algebraic equations work too. Equations are based on equality. In other words, if you add equal amounts to both sides of an equation or subtract equal amounts from both sides, the balance of the equation is maintained. For example, let us look at the equation 2 plus 4 equals 6. If we add, let's say 3 to both sides of the equation, we get 2 plus 4 plus 3 equals 6 plus 3. On simplification, we get 9 equals 9, which is correct. If we subtract 3 from both sides of the equation, we get 2 plus 4 minus 3 equals 6 minus 3. On simplification, we get 3 equals 3, which is correct. Similarly, if both sides of an equation are multiplied by the same non-zero number or divided by the same non-zero number, the equation stays in balance. For example, in the equation 2 into 3 equals 6. If we multiply both sides by 3, we get 2 into 3 into 3 equals 6 into 3. On simplification, we get 18 equals 18, which is correct. If we divide both sides of the equation by 3, we get 2 into 3 by 3 equals 6 by 3. When we simplify this, we get 2 equals 2, which is correct. So remember, when you perform an operation to one side of an equation, you must perform the same operation to the other side of the equation as well, in order to maintain the balance of the equation.